Like I promised, right? We did partial fractions, but now it's time for proof by contradiction. And that's not easy either. What you'll quickly realize is year 13, the reason why it's so hard is because you're not doing a method anymore. Trust me, it's about logical reasoning. They're trying to see, do you understand the theory? Not just, can you solve an algorithm? All right? So let's get started with proof by contradiction. Today, we have a question such that we have to prove that there are no integers a and b for which 25a plus 15b equals 1. So, quick breakdown on what proof by contradiction tests, right? The framework is that we have to assume the converse statement, right? The converse statement is the opposite. We assume that whatever we're trying to prove is not true, right? Once we've assumed it's not true, we have to mathematically deduce that our assumption of it not being true is bullshit, basically. And if it's bullshit, if our negative assumption is bullshit, then our original assumption must be true. All right, this is how you would go about it. So let's get started. Now, we are told that we have to prove that there are integers a and b for which 25a plus 15b equals 1. So our first step would be to assume the converse, right? The converse just means the opposite. Okay, if we're trying to prove there are no integers a and b such that 25a plus 15b equals 1, we have to assume the opposite, which means that there are integers a and b such that 25a plus 15b is equal to 1, right? We have to assume there are integers a and b. Now, if we've assumed there are integers a and b, now we need to do some maths to prove that this can't be true. First thing I'm going to start out by is looking at the left-hand side of this equation, 25a plus 15b. What do we notice? They have a common multiple of 5. And if that's the case, let's try and factor it out. If we do that, we are left with 5 lots of 5a plus 3b is equal to 1. Okay, which means that 5a plus 3b is a fifth. Now, why have we done this? Some of you might be ringing alarm bells because 5a plus 3b is a fifth. That doesn't really make sense if a and b are integers, but we'll still go through it step by step. So, remember, we assume that a and b are integers. Now, if they're integers, this must mean that 5a and 3b are also integers, right? And this makes sense because an integer is just a whole number. So if we multiply it by 5 or by 3, it should still be a whole number, right? So if a and b are integers, this implies that 5a and 3b are also integers. Okay, so if 5a and 3b are also integers, this must mean that 5a plus 3b must also be an integer, right? Because an integer plus an integer must be another integer. How can we add two whole numbers and end up with a decimal? That's not possible. So if 5a and 3b are integers, then 5a plus 3b must also be an integer. But hold on, what do we notice? We noticed that from before that 5a plus 3b is actually a fifth. This isn't what we expected, right? We expected 5a plus 3b to be equal to an integer. So therefore, we have shown there's a contradiction. So therefore, there's a contradiction. A contradiction occurs. Because we said they must add to an integer, but we haven't gotten that. So therefore, there's a problem. So 5a plus 3b is actually a fifth, which means there's a contradiction. So if there's a contradiction, this implies that our initial assumption, our converse assumption, is false. Remember, our converse assumption was that 5a plus 3, there are integers a and b such that 5a plus 3b is a fifth. That was our initial assumption. But we've proven that that can't be true, right? So our converse assumption is false, which means that our initial assumption is false. So remember, our initial assumption was that there are integers a and b. So if that is false, that means there are actually no integers a and b such that 5a plus 3b is equal to a fifth. I know the initial problem was 25a plus 15b equals 1, but we can still formulate it like this. So let's recap what we did. We assumed that there were integers A and B. This generally applies. You always assume the opposite. Whatever you're trying to prove, you should assume the opposite. Then we did some maths and showed that that can't happen because that does not obey the basic laws of maths. You can't have an integer plus an integer and end up with a decimal point, or sorry, a fraction. So therefore, if that's false, that means our initial assumption must be false. So therefore, we have proven by contradiction that 25a plus 15b equals 1 doesn't have integer solutions. Okay, cool. Hopefully that made sense. Proof by contradiction, it's a little bit tricky because this is the first time in A-level maths I believe you guys are actually reasoning and not just learning an exercise, learning how to do it so over and over and over again, where it's, if you see the same method, you know the steps, but you don't actually understand it. This is what they're trying to test. And if you understand that, there is no way you can't perform really well. I hope you guys enjoyed, and I'll see you in the next video. Thank you.